Baker Botts, LLP, provides podcasts for educational purposes only. They are not legal advice and are not intended to establish an attorney client relationship. This communication may constitute attorney advertising.
Welcome to AI Council Code. The AI Council Code is here to keep you up to date on all AI legal issues arising in the modern business frontier. I'm Maggie Welsh. I'm a partner at Baker Botts and I co-chair the AI practice team. Today I have with me Chris Palermo, and he's going to be discussing patent practices with respect to AI technologies. Hi, Chris. How are you?
I'm very well. Thank you for inviting me, Maggie. I'm delighted to be here to discuss the latest IP protection challenge for high-tech companies and IP attorneys. The past 30 years have been constantly disruptive as we've had to learn strategies for protecting things like object-oriented software, if you want to go back 30 years, internet systems, the web, cloud-based systems, social networking, the Internet of Things, blockchain, and now AI. And of course, AI has been with us since the 1960s. Many of us will fondly recall learning Lisp, Smalltalk, and other AI-focused programming languages in the 1980s and 1990s. So it's not really new. And then a few years ago, we started talking a lot about big data. And now the label has changed. The past year's widespread development of large language models, or LLMs, has been a game changer. And it's been a privilege for me to work on the front lines with some of the greatest inventors and innovators in those areas.
Great, thanks, Chris. And just for our listeners, why don't you tell everyone a little bit about your background, specifically your work in patents and patent prosecution, what you do on a day-to-day?
Sure. I have 30 years of experience in the field. My background's in computer science. Early in my career, I worked as a large-scale PBX and voicemail system programmer for one of the regional Bell operating companies. I have worked primarily in the field of patent preparation and prosecution for my legal career, and I've worked on inventions in all the technical areas that I just mentioned. Day to day, I spend considerable time working with companies ranging from early stage ventures, startups, through the Fortune 100 to identify what inventions to pursue, to select among many candidates the ones that we think have the best chances for success in the USPTO, the EPO, and other agencies. Then once we've made those strategic decisions, I work with CTOs, inventors, and other contributors to understand what the invention is, to describe it, to claim it, and to negotiate it with the government.
I'm a patent attorney as well, and I understand the importance and the value of patents. And when companies are thinking about patenting their AI technologies, what are some of the top challenges today that you see with patenting AI inventions?
Well, the first is teasing out the specific invention to be claimed. We won't have success in the examination or enforcement process typically if we merely claim a new, fabulously helpful application that happens to use an LLM or other machine learning model. That kind of application will suffer the same fate in the patent examining agencies as hundreds of applications in the early 2000s that covered cloudifying known things when the cloud was new. So we need to view much of AI as commodity infrastructure or foundation and ask what improvement the inventors have contributed. A second challenge is subject matter eligibility for experienced US practitioners, rejections under 35 USC section 101. The PTO's present view appears to be that certain combinations of data transformation or preparation, invocation of an LLM or other ML model, and transformation of the output, if claimed at that level, don't represent eligible subject matter. They think this is a business process wrapped around an ML model. So applicants will have to disclose a level of technical complexity greater than what I have just described. And a third challenge is the increasing sophistication of patent examiners. In at least the USPTO and the EPO, examiners won't suffer fools, if you will. The disclosure and the claims must be credible in the sense of not overbroad and must identify a technical improvement that the examiner can ascertain objectively from the specification. The best framing is in terms of defining a problem and identifying the solution. And storytelling in patent applications has been incredibly important in this field. The examiners know that AI and ML research is producing amazing advances almost daily. So the applicant needs to show the examiner what is new and different about the applicant's invention in clear terms. And then finally, the fourth challenge that I would see is defining claims that will be enforceable. Claims to training techniques or internal model architectures that are fully embedded or internal to a company and other parties may never describe in public documents may not offer much value because we can't determine that they're infringed.
Interesting. And it sounds like a lot of what you're saying requires patent applications describing the technology and the improvements in a lot of detail. Is that right?
The cases that we're writing in this area typically are 30 to 35 pages of text minimum and often 40 to 60. So they're at the upper end of complexity in what some people call software patenting. But the upfront cost and time involved in writing a thorough, robust description with alternatives and with sufficient detail that someone could reproduce the invention will really pay off at the prosecution stage by providing a subject matter that we can incorporate into the claims if needed based on the prior art that's found. So I encourage applicants not to skimp on the upfront drafting process.
And one point that you mentioned that I thought was interesting was just the increase of technical background of the patent examiners and the number of patent applications that are being filed at the USPTO related to AI inventions has exponentially increased. And so with that, I would think also the patent examiners are becoming more educated in this area or educated on what the advancements might be on a day-to-day basis, but also having to keep up with a vast set of prior art and prior art that's changing daily probably and being updated daily. That must be another challenge too, just keeping up, like you mentioned, with new products and new technologies coming out every day.
Indeed, it's important for practitioners to look for industry newsletters, technical briefings, blogs, and other sources of information on technical developments. And if you can't find them, then just resign yourself to the fact that the applicant companies, your clients, if you're in private practice or in-house practice, will always be ahead of you, and there will be a learning curve as new innovations are formed. We've had the benefit in the cases that I handle of doing repeat work for several companies that are at the core of the LLM revolution. And each case that we write really benefits from the experience and the relationship we've built with the inventors in terms of having a depth of understanding of what they're doing.
We've touched on some of the tips for patenting AI technologies. Are there any other tips that you would recommend when a company is looking to patent their AI technologies?
Well, I think there are a lot of opportunities. Fundamentally, in the strategic process of identifying what to pursue, we look at a number of things. Opportunities can arise in characteristics of the input data, pre-processing techniques, training techniques, the architectures of trained core models that evaluate input at the inference stage, engineered prompts to the inference stage, post-processing of responses, and end-to-end applications. So let's break that down. Patentable novelty could be found in feature engineering. That's the discovery that a subset of all the features of the training data is most predictive of useful output in the inference stage. For example, if a company uses a training data set that has 300 columns or 300 features, but only 20 or 30 of those features contribute to good predictions for a given input at the inference stage, then patentable novelty could lie in the discovery of which 20 or 30 features are most predictive. Feature engineering is the science of identifying those features, and patentable novelty often can arise from its results. So I encourage companies to look at what work their data scientists are doing upfront to identify what features in the big data that we mentioned are important. In the case of large language models or LLMs, inventors are devising complex multi-stage prompts that instruct the LLM what to include or exclude in the inference stage and the output. These multi-stage prompts can be abstracted into functional sections. They're almost like mini programs or portions of a template. And a patentable invention could lie in the structure of the prompt and its use in inferential prediction. So I've written patent claims recently to the structure and use of engineered prompts based on the functions that lie in different sections of them. The responses from an LLM also may not be usable in raw form and may need filtering, reorganization, or supplementation, and those could be additional process steps in a claim. Speaking of supplementation, we're also seeing patentable novelty arising from retrieval augmented generation, or RAG, R-A-G. A RAG system is programmed to first submit a query to a relational database, a document corpus, or another repository, and receive a result set back. That result set can be processed to extract keywords, snippets, or other useful information, which is substituted into a prompt template, creating the final prompt for the LLM. So the retrieval from the database augments the generation by contributing to the prompt. And that prompt causes the LLM to return much better responses for certain applications because the prompt has been biased or tuned based on the customer's specific requirements. So in that case, you could have patentable novelty in the structure of the queries, what processing is done after the result comes back, and the engineered prompt or its template. Another tip is to look at the core algorithms or architectures that are used in the ML models at the training or inference stage. Not everyone is using public APIs for LLMs. Some companies are using custom or customized or internally developed models. So a good question to ask is, what's our model? How's it configured? How's it architected? For example, I've worked on patent applications in the specialized field of topic modeling. This involves determining the topics that people have discussed in a conversation, for example, as evidenced by a transcript of a phone call with a customer service representative. Topic modeling uses statistical analysis of the text that is quite different from linear classifiers, neural networks, and LLMs that we see in perhaps 80% of AI-related patents, although topic models can be based on those things. You also might look at configuration data. If the company is using a public model, the hyperparameters or other configuration data that the company uses to configure the model to operate effectively can be a source of patentable inventions. And often extensive engineering effort is devoted to those parameters.
Great. Thank you for that explanation, Chris. And I think what's interesting for companies is to be thinking about their specific use case of their AI model, and that patentability extends if you're using the AI model, putting prompts into the AI model, and then using those outputs as well. Is that a fair characterization?
Yes, companies should definitely do that. However, they also need to be aware that the PTO may apply prior art across domains. In other words, if the structure of the solution is, in a general sense, similar to a prior art solution that was used in a different domain or for a different class of customers or users, then the submission could be invalid based on that prior art. We have very little experience with those kinds of cross-domain citations right now, but I anticipate that it would happen.
Thank you. Those are helpful tips for everyone listening to consider. One question that we often get from clients is just thinking about their inventions, if it's worth the value of patenting the invention or whether you should just keep your invention protected as a trade secret and not put it into a patent application. And for our listeners who are not familiar with patent applications, when you apply for a patent application, you need to provide the disclosures of the invention in the application. So what would you say to companies when they're thinking about whether to patent their invention or keep it protected as a trade secret?
Great question. I typically focus on how easily a competitor can reverse engineer the invention based on public information from the company, the IP owner, or the applicant. If an invention is easily reverse engineered because much of its structure and function is visible via a product, a website, public documentation, conference presentations, journal publications, or other disclosures that the IP owner makes in the ordinary course of business, then patent protection becomes a stronger consideration. If reverse engineering is difficult, then trade secret protection may be enough, provided that the IP owner takes steps to maintain trade secret protection, things like physical control of secured premises, effective contract clauses with personnel, and above all, proper management of people in the organization to create a culture of confidentiality. For AI and ML in particular, companies should carefully safeguard training data, trained models, model algorithms or configuration, and feature engineering data in the first instance, and then ask thoughtfully whether they are comfortable disclosing some or all of those things in a patent application. For outside counsel, giving advice on the patent versus trade secret trade-off really is only possible if you have a good knowledge of what information is valuable in the business of the company and what confers competitive advantage. So I encourage outside counsel to know their customer, to research and understand the companies that they're working with, and try to form a mental map of what information is competitively valuable and what is okay to disclose in a patent application, because the competition would learn it anyway if you didn't patent it.
Excellent. Thank you for shedding light on AI and patent strategies and intellectual property strategies. As we wrap up, are there any final thoughts or advice you have for our listeners?
The field offers tremendous opportunity. I think specificity in filing is important, to be realistic about what you can claim, and to understand that patent examiners are increasingly treating components of AI and machine learning as foundation technology that will not be deemed novel on their own. So applicants will have to come up with something more than general purpose AI systems as a basis of their claims. And the final thought is to keep in mind that the AI revolution relating to large language models is so new that many disclosures are not yet published. With the 18-month publication period for most patent applications in the US and overseas, the first publications of LLM patent disclosures have only recently started appearing. The velocity of those publications will increase over the next 6 months, but as we talk today, there's a tremendous mass of the iceberg of prior art that's still below the waterline that companies will not be able to see for some time.
Fascinating. So more to come and more disclosures to come for sure for companies to watch out for. Well, thank you, Chris, very much for joining us today. And thank you to our listeners for listening to the AI Council Code. We are so glad you joined us today. Stay tuned for additional podcasts and more insights on AI legal issues.
Thank you for listening to this BakerBots podcast. BakerBots has the experience, knowledge, and people to address our clients' most significant legal issues. For more information on BakerBots practices, please visit us at bakerbots.com. This presentation is provided by BakerBots LLP for educational and informational purposes only. It is not legal advice and is not intended to establish an attorney-client relationship. Under the rules of certain jurisdictions, this communication may constitute attorney advertising.